All right, let's go ahead and do this stuff and things right here. You need to turn in your book to page something something. Maybe I should be more precise on that, something something. It is page 236. Turn into page 236, and we're going to go over side, side, side. Okay, so this, we did skip 5.4, I'm aware. 5.4 is more of an algebraic problem section. So we're just going to do the proof ones, and then we're going to do that at the end. That way we start with algebra, have proofs in the middle, and end with algebra. And so just to give a little balance, make the sandwich. So this is theorem 5.8, but it's less than 5.5, but I already put that in the title, so I don't know I'm writing it again. So let's look at theorem 5.8. And this is going to be side, side, side. Got to write side a lot of times. Congruence. Theorem. Okay. So the important thing to know about this is, well, there's no angles. It's just side, side, side. And the nice thing about this one is there's no order. No order matters when it's side, 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 because we're dealing with triangles. And basically, there's three sides, so it needs all of the sides. Those aren't exactly congruent, but and the book is wrong. And it bugs me very, very much how the book is wrong. I guess I should write it like the book and show you how the book is wrong so we can correct the book, because that's always a fun thing to do. So this is what the book does. And D, E, F. Okay, and then it marks it up like bam, bam, bam. And then it does what? Here, bam, bam, bam. Maybe the book isn't wrong. Maybe it's right. But let's make sure it is. AB is supposed to equal DE. I guess the book is right. But make sure that these line up, and we'll just make sure. And I don't know I'm writing in red other than I have the red pen. So if it is too light, I will darken it up. All right, let's make sure the book is right here. Okay, let's see here. A, it's got a 1 and a 2, so A should be D. Actually, I should do it since it's sides. AC is going to go with DF. Let's see, AC, DF. All right, AB is going to go with DE. DE. Okay, we're good. It works. Okay, so is this going to have anything to do with angles? So if I'm doing a proof with side, 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 I am not going to use any of the tools that give me angles, right? I'm only going to use tools that give me sides. Okay, and for today, because we're not trying to do all of the proofs in one day, we're only going to worry about side, side, side. Side angle sides still exist, but today we're just worried about side, 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 and eventually we're going to combine all of them, and so we're going to be doing where you have to pick the end tool. But the end tool today is side, side, side. So that's basically what it is. So I'm going to give a proof right here, and we're going to see if we can work it out. So I'm going to draw the picture. And apparently I'm going to make it really big. That's excessively big. And if I drew that in the middle, it would have worked. So let's pretend like I drew that in the middle. All right, A. B, C, and D. And I'm going to give you your given. Your given here AD, line segment AD, is congruent to line segment CD. B is the midpoint of segment AC. That's it. So I probably can't do anything unless I tell you this. I want you to prove triangle A, B, D is congruent to triangle C, B, D. I'll move it a little bit down so you can just see what you need. Okay. Do you know the start? It's the given. Do you know the end? Isn't the end going to be this? So you just got to fill in the meat. Okay, and I like to have a little plan box. It's called a 2-column proof, but when I do it, I always draw 3 columns because I like to have this column just be my plan. Okay, some people can plan with the shape. Some people plan with this. There's different ways to plan, and I'm doing all the different ways. Well, not all the different ways. I'm doing a couple different ways. So the first thing I do before I even start anything is I'd mark up the shape with your given. Okay, well, I guess I'd write the given and then mark up my shape. That's fair. Let's write the given. Then we mark up our shape. I need to zoom out, or I need to do this. I don't think I can zoom out anymore. I'm going to focus it, which is really annoying on video, but it's better because it's high def on video, and so it gets really obnoxious when it's blurry. All right, I'll just write my given. That's fine. Okay, I'm going to write that as given. And now I'm going to mark up my shape. AD, CD. AD, CD. Is that true? I got one of my sides with no effort. Okay. B is the midpoint of AC. Okay, that's given. I don't really have to write given twice, but I felt like it. That doesn't actually give me anything. I have a word. And hopefully you've heard me when it says if I got a word, I'm going to have to change it. I'm going to have to change it into some kind of mathematical statement using the definition. So I'm not ready to do that yet. Now I can plan this out a little bit. I can use my toolkit. I can use my toolkit to look at what midpoint can do for me. I can look at the shape of the 2 triangles and see if there's some kind of hint with the shape, with the fact that they're touching. So try to get this done, and then I'll work after you. Okay, just looking at planning, I notice that they're touching, and I bet you I can do this. There's a rule for that. And since I'm doing side, 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 I really, really would like somehow to prove that this is equal to this. Does that make sense of what I need to do? Okay, does it matter if I do this part or this part first? It doesn't. I'm going to do this part first just because I feel like it. So I could write BD is congruent to BD, and that's segment BD. Make sure you put that segment over it. I sometimes squunch my stuff up. And that is because of property. Okay, so I just checked off my second side. I just need one more side. So I haven't used this given yet, so I bet you I need to use that given. And so what I said up here, just drawn on this, I really hope to prove that AB is congruent to, it could be either way, BC, CD. How can I say this? B is the midpoint of AC. I can say this by doing the definition of midpoint. Right? Midpoint creates two congruent segments. That's the definition. And that creates that. So now I have three sides. What else do I need to do? We got a conclusion. And that's going to be SSS, right? Okay. So that's basically the plan that we're doing here. We're going to do some work on this, and you guys are actually in great shape, where you got plenty of time to work. There's another theorem in this section, but I don't want to do it right now. I think it'd be better just to add one, and then just do one at a time. Tomorrow we're going to add two, and then we'll add the fifth and the sixth after that. So we'll just be doing that. So what we're going to do is we're going to turn on to the next page, and I'm going to kind of go over how to do some problems here. And I'm going to stop this because that's the main part of it.